Basically, what we are trying to do here is a kind of collab to show guys how we are working with Bluetooth low energy, how we are using our devices. How many of you are already familiar with Zebra? So I know you're familiar with Zebra, right? No? Something? But the other ones know Zebra does? See? Okay. So basically, we made software and hardware. Basically, we made hardware. We have different lines of hardware. We make printers, industrial printers. We make scanners. We make mobile computers. Basically, a mobile computer, we are actually working mainly in Android. We used to work also in Windows. But basically, after integration with, I don't know if you know that, but we buy the Motorola solutions 3 years ago. So when we did the acquisition, this is a very nice acquisition because normally it's the big fish buying the small fish. But in this case, the small fish was buying the big fish. So in this particular case, for us was very, very important to do a very successful integration. After 3 years, we have done a very good integration with all of the Motorola solutions that we implement. During that integration, we have a part what we have done is harmonize hardware. So we develop solutions, we develop hardware, and we harmonize those, creating SDKs, so developers like you can implement those very easily. So I'm going to start to do a presentation. Basically, my name is Manuel Caicedo. I work for the ISV team. ISV, everybody knows what is ISV. ISV, independent software vendor. So my role there is basically help ISVs to implement our hardware and software into their applications. I have been working with Zebra for 5 years. I have a master's degree in software engineering. Basically, my specialization is in Android and also in Java. Working basically, those are my focus. Part of the team working in other areas. So during the presentation, I'm gonna just, in some points, I'm gonna stop to show the code. In some point, I'm gonna show the demo. If you have any questions, please, you can do it. And during those parts, we can get a little more time to advance into the presentation. So basically, what I explained to you, we work for Zebra. Normally, we cover 90%, basically 95% of the Fortune companies. So just even all of the 19 companies like Amazon, all of the technologies companies use our products in their operations. During that, so basically, we covered many different solutions. We covered all of the options that you see here. We cover cloud solutions, location solutions, mobile computing, data capture, barcode printing. This is all of the hardware that we cover, and basically all of the vertical that we cover. We cover retail, manufacturing, transportation and logistics, and healthcare. So what basically is the agenda that we want to cover today? We want to cover basically 3 points. We want to go through the basics, what Android have done with and Bluetooth, how they implement Bluetooth. Some of you already know this part. So we want to just go quick. So that part, after that, I want to say how we did to improve that kind of part with our devices, peripherals, and hardware using Bluetooth low energy. So the first part, just review the APIs. The second part is how we simplify the APIs from the perspective that Android did through Zebra perspective. The last part is just showing you how we implement those kind of solutions using our peripherals, so basically printers and beacons. So if you don't know, we work in locations. How many of you know that NFL guys, we track the NFL guys using our technology? Did you know that? No? All of the NFL is tracking with our technology. So any player has 2 beacons on both sides. Each stadium has a full implementation to capture that information. So we work with our URF to doing that kind of thing. So we develop for them the hardware, the implementation of the stadiums, and also all of the software to do the analytics of that. So basically, we want to see just a basic implementation. We don't have time, just 40 minutes. So we want to just see a simple implementation with printers and beacons working as a peripheral. So the first thing that basically we did, comparing this through the work that Android have done, is basically analyzing what the Bluetooth allows us developers to do. So basically, the most important is that developers can do with Bluetooth is scan devices, right? You can query pair devices too. So after you scan it, you can save the devices. You can do that. Establish connections with the devices and transmit data. So you can do that through the FCOM channels. Also, you can transfer data from one device to other devices, manage multiple connections. The last part, as I explained to you, we want to use Bacon and Segura printers to see how we optimize Bluetooth low energy 4.1. Let's try to check 1 second both technologies, Bluetooth low energy. So when you start to work with Bluetooth low energy, you decided to first define the use cases. So each technology allows you to implement several use cases, but some of them work better for some use cases, other ones work better for other cases. Basically, what we are analyzing here is one of the use cases that normally you decided to work with Bluetooth standard is when you need to work in a range of 30 to 50 feet that allows you to connect those devices. When you're working with Bluetooth low energy, you need to work always less than 50 feet to the device. So it's one of the limitations that Bluetooth low energy can do. Other thing that allows Bluetooth standard is basically transmit high quantity of data. It was designed for intensity operations, but initially was designed to transmit high quantity of data into what we call quantity of data that is related, but allows you to transmit more data than the Bluetooth low energy. One more thing, so again, when you decide to work with Bluetooth, it's because you're working with mobile devices. So you're doing something with mobile devices. So it's basically battery operation devices. So when you're working with Bluetooth low energy, you're working basically with very intensity battery operations. The last part, Bluetooth standard allows you to control up to 4 or 5 levels of security. Against Bluetooth low energy don't allows you to control all those kind of securities, but it's because it's, when you analyze that, it's because you're working basically with devices that you're connecting as a beacon, so no, like we say, it's more devices, more slave devices. So basically for IoT activity. Question here? No? Okay. So let's try to go through a brief review of the Android APIs. So the first thing that we want to check is the Bluetooth permissions. So basically, those are the standard Bluetooth permissions. Everybody knows that after Android 6.0, everybody has started to see issues with Android connectivity. And basically with discovery. So the discovery option, you need to activate the access code location in order to use discovery after Android 6.0. And the last part is I just doing both things together. So the things that are similar between Bluetooth low energy. I'm going to be focused more in Bluetooth standard. Bluetooth low energy is a little more extensive. We don't have time to cover that. But I just made some differentiation between both. So the second part that you see there is basically you're working in Bluetooth low energy. And that was part of what I tried to mention at the beginning. You can identify is your device Bluetooth low energy, doing that portion only. The second part, if you're working with Bluetooth, the first thing that you need to work is with Bluetooth adapter. Bluetooth adapter is basically the object in Android that identifies the Bluetooth connectivity, Bluetooth use. So you need to enable the Bluetooth adapter. Basically, you need to define first if your device supports Bluetooth. And after that, the second thing that you need to do is enable the Bluetooth adapter through that kind of portion of code. So basically, the similarities in that portion is similar. What you need to do is enable the request enable Bluetooth. In order to do that, it's similar to the Bluetooth low energy. The second thing that's the only two things that are basically the same, three things. Android Bluetooth permission, Bluetooth adapter, and enable Bluetooth. From there, Bluetooth and Bluetooth Low Energy has completely different implementations. Bluetooth Low Energy has completely different stack than the Bluetooth standard. So based on that, Android just made a lot of work just developing some classes for Bluetooth Low Energy and other classes for Bluetooth. And that was the part that we did in our company to homologate, to standardize those kind of things. You will see those things later. Okay, so just going to Bluetooth Low Energy, the Bluetooth standard, you need basically, in order to do the discovery part, you need to create basically a broadcast. Everybody have been working with broadcast here, but you need that. You need to implement the Bluetooth device action found in order to find the devices around you. Basically, you need to register and unregister the broadcast. That's basically the option that you need to do. After, this is basically how you implement the broadcast receiver. Normally, it's into the broadcast receiver. Normally, you need to register the broadcast in your onCreate method. So you need to put that into the onCreate method. How that works, basically, your device has to be enabled and also be able to be found. So when you do the discovery, that's the action, the state that Android devices will recognize that your device was found. Once you have a device found, the Bluetooth device do a communication, basic communication, and you will connecting the devices together, and you will getting just two basic information. Basically, you can get you get the name of the device and the address of the device. Doing the discovery, we are talking about the discovery. So you say that information into your application, and after that, you will be selecting that MAC address to do the connectivity to the specific device. Okay, there are two options to connect the devices, connecting as a client and connecting as a server. So when you're connecting as a server, basically you are making able the device to open the connections. When you're working with a client or as a client, it's because you are seeing a server sending you or a device open to receive connections. Normally, when you're working with mobile computers, you're working as a client. So backends or other devices like the printers working as a server. So they are open to receive communications. So it's one of the portion that we analyze here. So in our particular case, because we are developers, we are developing the side of the client. So we will be needing this kind of development. So what Android recommends, basically, they recommend to put this in a thread to make the connection. You need to create a temporary Bluetooth socket connection. Into the block socket connection, you will use this method of the device that will create the channel to open the communication with the Bluetooth device, who is sending the signal to see that it's open to open the communication. So that's the first part of the code. I have just explained the code in several parts. So don't forget to always close the client socket once you have it finished. That's part of the final part of the implementation. So when you finish with the communication, you need to close the socket. Otherwise, you will have some issues trying to reopen or to reconnect the device. So it's always recommended every time that you do that, close the connection. And we have seen that many times when we do the connection with our printers and with our device. So always we try to talk to the developers, close the connection. Sounds supposed to be Android is based in Java, and that doesn't mean, like I am the Java developer, that doesn't mean against for example, C# or C++. They tell you exactly that any object or pointer that you open, you need to close that. So you assume in Java you don't need to do that, but you need it. When you're working with sockets or when you're working with devices and objects, you need to close those connections. Okay, basically, what you need to do is because you're working, when you open the connection, you're working as a final. So at that particular moment, you need to define the variables as a final. So that was the reason, because when you were looking for the device, open the connection, you create a temporary connection, and after that, the connection is created, you convert that to final. So basically, here is how that implementation works. So you remember the first part, we have two options here. We have the socket, the input stream, if you want to receive data, output stream, if you want to send data. The implementation is very simple. You create the temporary input stream to receive the data. You create an exception, IOE exception for interface communications. You receive the data. If you have any problem receiving the data, you will get that there. Through the debugging, you will see those kind of things. Part of the question that you asked me at the beginning. If you create that kind of exception and you can follow that debugging, you will be able to see this creating the problem after the communication is created, is capturing that error or that exception, receiving the data or sending the data. One of two could be happening. Yeah? So either one of those, you will have two different options to communicate with those devices. And basically here is just the routine to write to the device. It's very simple to implement. You need to implement a handler to create that. You need to send a message and wait for the message from the device. Once the device, the message from the device have received, you will know at that moment if you are able to keep the communication or close the communication. Normally, when the initial communication is not accepted for the mobile device or the beacon of the slave device, immediately the communication will be closed, and that happens through a message. So if you have some issues during that process, the message will tell you what happened at that moment. Basically here you need to use, let's go to the next one. Here basically you need to use a buffer. In the buffer you will create your data that you need to transmit to the device. And basically just you send the information through the mainstream, outstream, so you're sending the information through the buffer using that portion. So that is what Android have done for Bluetooth. So it's very easy, nothing new there, right? When comes the issues, right? When the issues coming through us. So here you see on the left is basically what our developers in Zebra have done to simplify the Android developers' work. So there are basically two main actions that you will be doing with Bluetooth devices. One option is discovering those devices in your environment, close to you. Basically, that's part what normally you do. You have two ways to do it. If you know the Bluetooth, just basically you work directly with the Bluetooth and you just take out the discovery portion of that. But we are assuming that we need discovery. So in this discovery, you need to implement some part of the implementations to find the device that was discovered, to say the device that was discovered, and to implement that selection when the device was discovered. So we create basically three options to keep that information easily. We saw those kind of particularities against the standard discovery. In discovery, normally you use an activity to devise and scan device through the broadcaster or through, yes, basically the broadcaster. Basically talking about the Bluetooth standard on the right side. So use the broadcaster receiver. Normally you need to define an Intel filter, basically what we saw before, register and register receiver. For the communication, basically you have three main classes. So the Bluetooth adapter, basically that's the most important one. The second one is the Bluetooth device. So this is basically the object that you save of the device that you try to use for the communication. And the Bluetooth socket, basically to create the channel and to send the data or receive the data between both devices. So that is Bluetooth. This is Bluetooth low energy. So in Bluetooth low energy, because we are using a completely different stack for Bluetooth low energy, Bluetooth have implement all of those classes. So when you're working with Bluetooth low energy, it's simpler because you're working with slave devices, but it's more complicated to do a very simple application. Yeah. So what our developers did is using communication, we just capture both things and simplify those in three basic classes. So the Bluetooth connection, that's basically who take care of the connection with the Bluetooth device. The connection itself, when we talk about the connection itself, for us is an interface. What it basically means, normally you connect a device. In our cases, we connect the device through Bluetooth low energy, through Wi-Fi, through USB. So that's the reason because our connection is interface. Yeah, so allows you to connect any kind of those different objects of communication. Once the communication have been done, you start just to do the connection. In our case, you define the Bluetooth connection as the main object. So, for example, in our case, if you have a TCP connection, you have an object for TCP connection. So you do the discovery in TCP. Capture the TCP connection, goes to the connection, that is an interface, and after that, you start to work with the Zebra printer that will be something like the Bluetooth device in Android. In our case, the Zebra printer could be a beacon, but the Zebra printer will be the object that we take of the device that we use. It's because I want to explain to you in the next slide what that means. Any questions here? No? Everybody familiar with those classes, right? How many of you have been working in Bluetooth low energy now? How many of you have issues with Bluetooth low energy? Okay, that makes me feel better. Good. Okay, so yes, so you can see what one of the reasons is why many people have issues with Bluetooth low energy. Okay, so what basically we did that, or what basically we do this work for developers. So basically, those are what we think are the 5 reasons for us to develop the SDKs for Android developers or for enterprise developers. The first thing, our SDK is based in customer needs. So that's the reason because you see here Zebra printer class. Yeah, you know that you're working with printers, so you will have your classes for Zebra printer, and all of that is designed because portion of the communication in Bluetooth has to be developed in the other side of the peripheral. So normally in companies like us, you need to, that's what we say, harmonize hardware. The way that works one device against the other device doesn't mean that both devices will communicate and will be doing that very easily. No. In our cases, we need to harmonize that kind of communication, making some devices working as a servant, and making other devices working as a slave, or working as a client. So that is transparent to the developer, because the developer basically what we'll see is the SDK with the options that they need to do the implementation very easily. So again, so that is one of the reasons. Customer base, we try to solve the customer needs, and into those customer needs, we define basically what kind of classes needs to be done in the customer side or the developer side to make those kind of things easier. The second thing, we resolve process complex tasks. If you see here, basically on communication, we have simplified all of those classes. Even if you compare that with through Bluetooth, could be the initial approach. But as you see the communication in Bluetooth low energy, you have I don't know, about 10 classes to do a simple connection or to send simple data. As you see in Zebra, we just have it reduced all of that complexity to basically 3 classes. 3 classes. So you see that easier, but our developers spend almost than 6 months trying to do that, because remember, our connection class is an interface. So means that any device and any type of connectivity has to work the same way. Even behind of that is not the reality. So so we resolve the communication Android classes. We resolve latency connections. We resolve the issue with filtering devices. We also implement additional security options. Faster implementation. So as you see, part of the make the implementation faster is to reduce those classes to very optimized number of enumerators, interfaces, and classes. The last thing, or the most important that every company does, technology adoption, right? So why we say technology adoption? Technology adoption because basically we create those devices. This is new. This is no, even you see here, this is not even launched to the market. I try just to show you here. It's not launched to the market yet, and it's our device, it's new, doing testing at that moment to verify that everything is working fine. So this device basically works in LinkOS. LinkOS is the technology that we invented. So basically, it's operating system to work with all of those devices. So either this device, any kind of printer in Zebra, whatever you see in Zebra, is a printer using the same operating system. Could be this small, a small one, or the biggest industrial ones that like Apple, General Motors, everybody using the manufacturing side. So any of those devices use the same operating system. We developed the operating system. It's a LinkOS operating system. And that is the adoption of technology that, as a developer, we are creating for developers. The second thing, we are integrating different interfaces with the devices, or different technologies into the devices. So the hardware, basically, we are working here with Bluetooth Low Energy and Bluetooth Standard. And also, we have a Wi-Fi, we have NFC. So our devices support NFC too. And also, we are supporting RFID. So all of those technologies makes a little difficult for developers to work with. So that's another reason why we need to develop a specific SDKs for developers and solve those kind of things. The third one, communications improved. Bluetooth standard support up to 79 channels. Bluetooth Low Energy support 40 channels for communication. We don't need all of them. Basically, we are using only 2 channels. One channel to status check, and one channel for communication, so for send and receive data. Yeah? So that's basically an optimization, because normally you don't need to spend time trying to how can I say this, cover all of the bandwidth with other channels. Just you know that you need 2 channels, so you can expand your bandwidth using only those 2 channels. So that is one of the reasons that you optimize communications. Another important thing, when you work with the Bluetooth communication, we improve the communication. So the communication between both sides. Again, when you're working with those devices on hardware, we need to harmonize who will be working as a server, who will be working as a client. So that allows us to implement and improve our bidirectional communication. One of the parts that normally we offer and differentiate for the competitors, but allows us to tell customers that we allow bidirectional communication. So you can capture a lot of data from our devices, and you can now, you know that we are in the analytics stage now of the moment. So basically, whatever you're doing with analytics or with data, big data, is important for the companies, because that helps maker decisions, or the decision maker, to make better decisions. So whatever you're doing now, you need to think in big data and how you provide the big data. So all of those devices that you're working provide that big data. So that's part of what, for us, is very important to have bidirectional communication. The last part, maybe one of the most important things, and that's the reason because we are here. There are dedicated teams to support the SDKs, to provide to capture customer requirements, to hear voice of the customer, also to implement best practices and provide channels for developers to do those works very easily. So we have several best practices document. I recommend to you the presentation of the team will be posted in some moment later. So you have 2 links there. You can go to best practices printing apps. And what we are doing there is telling to developers how is the best way to implement those kind of applications to make the things easier for you guys. We have a several developer portal. We take all of the information from you guys, everything that is not working, capturing error cases, and providing online support through posts or conference guys like us, providing you on real-time response, maybe. But unless we capture the information from you guys to get that information. So basically, those are the main 5 reasons why companies like us develop those SDKs. So now, what we do with the SDKs. So basically, that is one of the standard use cases that you will face in the market. So printing a dynamic receipt. This is basically could be many different use cases, but this is just one case. That's the way normally we work, and we teach developers how to work and facilitate the work for the implementation of the application. So in this particular case, we have devices, what kind of communication you can implement. Formatting language is, are you not familiar with that? CPL is the language that normally we create to communicate with our devices, or in this particular case, with our printers. So which platform are you working Android, and how you will transferring that data. So basically here, on your right side, that's the code that I'm gonna share. Somebody want the code, I can share the code for you guys. So basically, it's a simple application how I implement all of those steps. So the discover and connect is basically, I'm gonna do the demo later after this presentation, after this slide. Basically what you do is discover printers, all of the process that you do during the communication. You do discover process, select and connect the device, and save the printer profile in the application. This is a standard process that everybody that's working with Bluetooth is doing. When you work with NFC, you can save and reduce those steps to one. That's one of the advantages to use the NFC. Well, okay, advantage and disadvantage, because normally when you work with the NFC, you need to touch your devices or very close devices. When you do the discovery, it's because you have 30 feet around devices that you need to find and connect them. Yeah. After that, you do the setting and formatting. Basically, depending on the devices, we have multiple devices, so we have a multiple printer language. So you need to select the right language. And after that, you start to do the process of the application. And after that, just you do so remember, you did the communication on the top part, but you basically you are not transferring data at that moment. You're capturing the MAC address of the device. So the moment on the bottom part is where you're doing the transferring data. So you open the communication again and send the data to the device. When you're working with, and this is a nice thing to show you how we work with this. When you're working with Bluetooth standard, you can transfer image to the printer in Bluetooth, but you cannot do you can do it. So you can do the same thing in Bluetooth Low Energy, but the differentiation in time is almost, so in Bluetooth standard, normally you spend 1 second to send the data to the device. When you're sending the same image to the printer in Bluetooth Low Energy, normally you spend about 8 to 10 seconds. Because everybody knows that Bluetooth Low Energy transmits very few packets of data many times. So the same data, the difference is the type of the package. So in one package, you're sending all of the data in Bluetooth standard against, 10, 20 packets in Bluetooth Low Energy sending the same data. So that is one of the differences to work in Bluetooth Low Energy, and how we solve that issue using templates. So basically, our printers can save all of the template information into the printer. So what we are doing is sending only the dynamic data. So when you send the dynamic data, you are optimizing the Bluetooth connectivity. So there are ways to optimize that. So when you, for example, again, so you're sending to a device the same data multiple times, so that data can be saved on the device if your device allows to do that. So that's in Bluetooth. In Bluetooth, because the printer doesn't matter, it's Bluetooth Low Energy. So they save the information here. But in Bluetooth Low Energy, you're sending only the small quantity of data, so small streams or bits that the printer will react very immediately, so you don't need to send all of the image that you were sending previously, because you saved the image in the printer before. So that's basically the way that we do status check, just to verify that the work that you were doing was successfully done. And the last part is just close the connection. Even you need to close the connection with our devices always. You never keep a connection open, because you're working with mobile devices. Mobile devices means you're working with batteries. So you leave a connection open. Bluetooth has that kind of problem that consumes a lot of energy of your battery. So normally, when you close the Bluetooth, that helps you to save energy a lot. So that's one of the reasons because the Bluetooth Low Energy was created, to save the consumption of the communication in Bluetooth communications. Our architectural SDK base, what is covering everything here, we have basically implementing printer discovery, connectivity, phone conversion, graphic conversion, all of that. All of that information is available on the right side. So what I'm gonna do here is I'm gonna do a short demo. Let me see if I can do it. So, okay, so let's see if this demo works. So you want the code, let me know. I have my USB memory here so everybody can take the code. So basically what we are doing is implementing the concept that we have seen here. The first thing that we want to do is discover the printer. So here you're seeing is this, all of the Bluetooth devices that are around this area. At this moment I know which is my printer. So I'm going to look for my printer here. Wow, so many devices here. And I'm going to look again. See again. Okay, so I found it. So it's the third one is my my mobile printer. So I'm going to start the process. I did the discover, I select the printer. I'm going to pair the printer. So it's the printer is pairing at this moment. Okay. So what I'm going to do is now send some data to the printer. I'm going to create. So I'm just basically doing this is an example of how you can create your own print receipt application. It's very nice that you don't need to sign in paper. You can sign on the application and you send to print. Let's see if that works. So very simple implementation how that works. And as you see here, for all of this, what you have seen here, I'm going to just pass the information here, has data, dynamic data, logo, image, whatever you can see, even a barcode scanner, whatever you need to do implementation. So everybody needs the application. How we did that is basically let me know. I can share with you guys the demo, so you can do that on your own. So let's go back to the presentation. So this is basically in doing. So somebody sending data? Yeah. Okay. Very nice logo. Okay. So that is one of the reasons why you need to implement security connectivity to avoid those kind of things. Right? So let's look the USB connector. You are, right? Somebody send me the data key. Okay, nice. Okay, good. So that means everybody's connected to the point we are making here. Let's go back to the presentation. Okay, so what you see there is basically a simple implementation. Our device. Thank you. And everything that you saw in that demo is done with this SDK. All of that kind of implementation done. We have a lot of sample code demos and documentation that you can take for that from our those links. So at the moment that you have the presentation available for you, you can go to those links and take that information. Okay, basically here is how we simplify all of the process just with that portion of code. So what you're doing is at the top part, basically you have two classes. The connection is basically the interface, and the Zebra printer, that's the object of the printer itself. Yeah? So we are emulating all of the functionality of the printer with the object Zebra printer. So basically what you do is, first of all, get a connection with the Bluetooth device. So you get the MAC address after the discovery function. Then the next thing that you do is open the connection. And after the device is connected, or the socket is open at that moment, you start to, the first thing that you do is capture the object of that device. So at that moment, you're capturing all of the profile of that device into the application and save it in printer. What you do after that is basically set up the device to CPL language, store the format that you're using just to optimize the communication in Bluetooth. And the next thing is, before to do the communication normally, because we are using smart devices, you need to talk to the device and ask the device is ready to do what we want to do with that device. So in our case, what we want to do with that device is print. So we want to ask, is you ready to print? So the device will tell you yes or no. So if the device is telling you, I am ready for printing, so after that, you will do the printing portion of that. So you will print the format, and after that, you will controlling the device is doing what you told them to do it. So you will have a successful check at the end to see if the printer did that. After that process, you close the connection and disconnect the device. Simple implementation, and all of the process that you saw is done in this particular slide. So how we optimize the use with the Bluetooth Low Zebra Peripheral device. So our printer, as I told you, let me see if I can show you that here. Let me see if I can do it here again. How many? Well, okay. Let's go through this quickly. I don't have much time. So let's try to do this. So in our offering, we have different kind of things. So we have mobile computers in Bluetooth Low Energy. All of those devices that you see on the left is mobile computers that we have in Bluetooth Low Energy. On the right side, we have the peripherals. So we have printers as peripherals. And we have beacons on the bottom. So every time that you remember now this presentation, you remember that we work with locations solutions, so we work with beacons. So we implement those beacons in many different places. In addition to the NFL, we work with the retail stores. So everything that you're doing, or when you go to retail store, what you're feeling now, or you're doing now, is basically approaching to those things on the stores with those beacons. They will let you know who you are, what you're doing there, and they will recommend to you specific kind of things to buy, or at least to identify your customer behaviors. So even if you're not buying something, or you buy something, or the device is not telling you what to do, the company is taking that information just to define your customer behaviors, and that allows later to the company make better decisions. So here I have another demo. That's basically working in Bluetooth Low Energy. See if that works. Okay. See if I can do this again. Okay. So basically here, you're using your printer as a beacon. So basically, it's working as a location solution. So this is working in Bluetooth Low Energy. So you're using RFID, basically works as a Wi-Fi. So you know the Wi-Fi controls the intensity of the signal depending where you're located. So the same thing works with Bluetooth Low Energy. So if you're close to the device, the matrix of the intensity of the signal is stronger against when you're far away from the device. So that allows you to do many different things with those Bluetooth devices. So in this particular demo, what we did is basically do implementation as when you're approaching to the device, and that makes sense with the part that I was mentioned to you before, is identifying who is close to you and basically implements the connect to that device, get information, or send some information to that device. Yeah, so if somebody wants to have the code for this, let me know. We have the sample code too. This is another demo that we have for Bluetooth Low Energy. So let's try to go to the end. So we have so that's basically how we did the implementation with Bluetooth Low Energy. This is part of the sample code. The permissions are basically the same permissions, just you are adding the find location to here. Normally it's required to work with API 23, so that's the API 23 version that we are using for this demo. Basically, what you're doing here is taking the APK from our Bluetooth SDKs. So two things. For Bluetooth standard, we have one API, and for Bluetooth Low Energy, we have another API. The same classes, but one for API for Bluetooth standard and the other one for Bluetooth Low Energy. In here, basically, how you can work with the callback part and making the implementation of the printers as a beacons. On the left side is just the sample code that we did just to make this work. Here, basically, what I explained to you before, how the proximity to the device works and how you implement that in Bluetooth. So the same thing that you saw on the video, short video that we show, how you are connecting the device and through Bluetooth Low Energy, detecting the device through basically location portion of that device. So you're using here the NFC capability to do that. Again, here so there are two processes here. That is a nice thing to do. So basically what we did here is two things. So we work in Bluetooth Low Energy to define the location of the device. And after we move to Bluetooth standard to send the data. So we did that conversion on the fly. So the user didn't see anything, just it's implemented with the code. So here we are open the connection, sending the data, and printing the information on the printer. That's the other components that we have for MPAT. MPAT is all of this technology that we have here. So those are the beacons that you don't see on retail store, but those are right there, taking your information from your Bluetooth devices, like the guy who is playing with my printer there. Okay, so that is basically what we do, network access. All of those parts are the components of the SDK for that portion. Here on the left is basically a standard architecture that normally is implemented when you're working with beacons. This is the code, the basic code that you do. We have sample code, and we have some demos that you can download from our website to do this implementation. Everything is ready for you, how you can implement it, how to do that. That's the other part we want to mention, our NFC devices. So you can, as I explained to you before, you can do all our devices. Most of our devices come with the NFC tag here. So you can do quickly connections and transmit data through that very easily through this new technology that basically you're seeing on the screen is what the tag has and how you can work with that. So how many of you have been working with NFC? No? Nobody? Nobody have been working with NFC yet? Really? Okay. So basically, our printer has a tag, RFID tag there. It's a passive RFID tag. Normally, when you're working in RFID, you have two ways to work in RFID. For example, again, coming back to the case in the NFL, NFL works with a different RFID. It says active RFID. So the players are sending the signal to the collectors. Yeah, in this particular case, this is a RFID passive, so you're capturing the information from the server who's sending the signal to that. And that's basically what it is into the device, how you capture the information. And basically what you do is approach your device, capture the string, and capture the MAC address. That's the second line. And after you capture the address, the MAC address, you can implement your connectivity the same way that was done before in Bluetooth. And that's it.